Hi Andy, good morning. So this is again Dr. C.H. Kiran Kumar dealing you the machine learning part. Today, let us move on to the new chapter called as rule models. Rule models. See, yesterday we talked about tree models. These all come under logical machine learning models, my dear friends. There are two logical machine learning models. There are tree models and rule models. Now we are going to talk about rule models. Rule models. Right. Rule models are the second major type of logical machine learning models. So these rule models offer more flexibility than tree models. Rule models give more flexibility than tree models. Particularly in supervised learning, a rule model is more than just a set of rules. The specification of how the rules are to be combined to form predictions is a crucial part of this model, my dear friends. Now, how to combine the rules to form a prediction? How to combine the rules is the task. There are essentially two approaches to supervised rule learning. There are only two methods. The first method is what we have done in decision tree learning. Find a combination of literals, the body of the rule, which we previously called a concept. So we learned in fourth chapter concept learning, and or not, negation, conjunction, etc. No, body of the rule. So that covers sufficiently homogeneous set of examples. Homogeneous set of examples. Derive some concepts. Find a label to put in the head of the rule. This is what it is. Find a combination of literals and derive some concepts which covers homogeneous set of examples. Okay, Rakamina 20. And find a label to put in the head of the rule. This is the first type. Second type approach goes in the opposite direction. First, select a class you want to learn, and then find the rule bodies that cover large set of the examples of that class. See, this is how we have to go maybe. And then find the rule bodies that cover examples of that class. Select a class you want to learn. So almost reverse direction. We have to go in the reverse direction. The first approach naturally leads to a model consisting of ordered sequence rules called as rule list. But the second approach treats collection of rules as unordered rule sets. Unordered rules set. So this, right, the first approach we are going to learn in this first chapter as 6.1, and this will be as 6.2, and the third section of this chapter covers discovery of subgroups and association rules. This part is called as 6.3. So this is what we are going to learn in this chapter. Learning ordered rule list. First part. The key idea of this kind of rule learning algorithm is to keep growing a conjunctive rule body by adding the literal that most improves its homogeneity. Right. The algorithm is to keep growing a conjunctive rule, my dear friends. Growing a conjunctive rule. How do you grow a rule? Just by adding the literal. Just by adding a literal. No, one rule is there. For that particular rule, we add a literal. How do we add literals? By conjunctive. Conjunctives are there, no? A union, intersection. See, De Morgan laws, negations, and all by using all these things, we can add literals to all rules so that it improves homogeneity. That is, we construct a downward path through hypothesis space and we stop as soon as homogeneity criterion is satisfied. See, we have already seen tree construction, right? We construct a downward path through hypothesis space and we stop as soon as some homogeneity criterion is satisfied. It is natural to measure homogeneity in terms of purity as we did with decision trees. Homogeneity in terms of purity, how pure it is, what is the error rate. So this is what we have to discuss again. Right, learning, adding a literal to a rule body is nothing but splits in the instances covered by the original rule. Right, it forms into two groups. Adding a literal to a rule body definitely splits the instances covered by the original rule body into two groups. Okay, literal, if you add one literal to the rule body, automatically the instance space is divided minimum into two groups. One, those instances for which the new literal is true. And those for which the new literal is false. True and false. Difference between tree model and rule model we have to discuss. No, we are talking about adding a new literal. Definitely splits. All truths are at one side, all falses are at other side. In decision tree learning, we are interested in the purity of both children, which is why we used weighted average impurity as our set heuristic when constructing the tree. But in rule learning, my dear friends, on the other hand, we are only interested in the purity of the children, the one in which the literal is true. This is what we are concerned only with. When the literal is true, that is, if it is false, we don't mind, or we don't put any interest towards the false one. We completely take care about the true part only. So we are only interested in the purity of the one of the children, the one in which the added literal is true. This is rule, right? It follows that we can directly use any of the impurity measures we considered in the previous chapter without the need of averaging. So no need of averaging the things. We can follow either one. So we have discussed now Gini index, square root of Gini index, entropy, weighted average, anything can be possible, but no need of averaging them. This is what it is. Right. Now let us go on learning what is called rule learning. In rule learning, we might take the proportion of the minority class min of p hash 1 minus p dash. P prediction min of 1 p comma 1 minus p, which is our impurity measure of choice. This we will discuss in detail in the coming sections. But remember, we are going to take, this is what it is. Min of p comma 1 minus p. Min of p comma 1 minus p. Whichever is minimum, we are going with that. Right? Let us go. Right. Let us consider the our dolphin data set with positive examples and negative examples. Remember, if you analyze this, if gills is yes, there is no positives. If gill is yes, there is no positive, my dear friends. If the gill is yes, there is no positive. And we are going to consider only yes parts, true parts. We are not going to consider the false parts, right? We'll see this, right? The 9 possible literals are shown with their coverage counts in figure 6.2. See, this is how it is shown. This is right. If you see here, true, there are 10, 5 here and 5 here. So 5 plus and 5 negatives. This is shown here. 5 plus 5 negative. And if you see length is equal to 3, length equal to 3, there are no 0. Length 3 in appudu, the number of negatives are 0 and positives are 2. So that is why it is shown as 2 plus, and this is called pure positives. Pure positive. That is why in the graph it is shown like this. This is shown like this. This is called pure positive, my dear friends. Pure positive. And similarly, if you see gills is equal to yes, gills is equal to yes, that covers all these negatives. And there is no positive in this. That is why it is shown as pure negative, pure negative. And this is shown here as this. This is pure negative, pure negative. Similarly, if you say bake is equal to no, bake is no, it is also come under pure negative. Later we decide, because this is not required, no? So we have already covered with this, gills is equal to yes. No need of this actually, but still we'll just consider what are all the, see, this is also called as pure negative. That is why it is shown like this. This is shown here. This is shown here. Similarly, we can consider all the things and see 1, 3 minus, see 1, see 5, right? This is shown 5 positives and 1 negative. 5 positives, 1 negative. See, similarly, right? Incline, see the angle is shown here, my dear friends. The angle, if the angle gets increased, it is going towards negative. If the angle gets increased, it is going towards the negative. That is the meaning. That is how it is written. Angle is important. That is why. See here, right? 3 of these are pure. This is pure positive. This is pure negative. This is also pure negative. Impurity isometric plot in 6.2. This is 6.2. One of the literals covers 2 positives and 2 negatives, and therefore has the same impurity as the overall data set. Overall data set is 5 plus and 5 minus. And some 1, 2 plus, see, like this is what it is. Length is equal to 5 if you see 2 plus and 2 minus. And therefore has the same impurity as that of the root. So this literal ends up on the ascending diagonal of the coverage plot. This is what it is. Anyhow, so this is how rule-based, right, learning will come, right? Now, impurity values are color coded. Towards green, p hash is greater than 1.2, greater than 1.2, greater than 1.2, my dear friends, plus 1.2. Avanni kuda green lo rasamu. And towards red, p is less than 1.2. Towards red, less than 1.2. And orange is equal to p is equal to 1.2. These are called orange. And towards red is less than 1.2. Towards red is less than 1.2. And so this is what so right, this is how it is on a 45-degree isometric. See, this is how the degree is estimated. This is how it is. This is so 45 degrees is acceptable. This is acceptable. So this is how now the violet arrow indicates the selected lateral, which excludes all 5 positives and 1 negatives. All 5 positives and 1 negative. This is what it is. Anyhow, this is how the right true 5 1, because we have taken no, this is the if we take this into consideration, if gills is equal to yes, then class is equal to empty. Automatically, we are left with 5 plus and 1 minus. 5 plus and 1 minus. And the length, it is right, and teeth is equal to many. And we have come to with what is called 1, 2, 3 purity sets are available. Now 3 purities. With only one rule, we have come to 3 purities, and which can easily be represented as negative. Positives are negatives. This is how a rule-based learning, rule-based, after every rule, no, the space, hypothesis space becoming, no, lesser. This is the rule. Right. Rule learning algorithms now proceed as follows, my dear friends. They remove the examples covered by the rule. See, the covered by the rule just learned from consideration. See, and proceed with the remaining examples. Now, if you see here, gills is equal to yes, and then class is equal to empty, and chapter so we have almost eliminated all these 4. And we are left with 5 positives and 1 negative. See, this is what it is. This is what we try to so show 5 plus 1 minus. With one rule. If I place a rule, I will be deleting all the negatives which are covered by this rule. So, and we will be proceeding with the remaining examples only. This strategy is called separate and conquer. This is not divide and conquer, my dear friends. This is called separate and conquer. Separate and conquer. So we end up with one remaining subproblem. So we are left with 5 positive examples and 1 negative. And we again search for literals with minimum impurity. Let us see now again. After going through the numbers, we find the next rule learned is, let us take the next rule. Next rule is, if teeth is equal to many, then class is positive. If teeth is equal to many, then class is positive. Let us take this rule. Teeth is equal to many, then class is positive. Why we have chosen this rule? See, see, these are all covered. Now we are left with, see, 1, 2, 3, and this is few. No negatives are being covered. So we have taken 1, 2, 3. As 3 things are being covered, now out of 6, 3 things are being covered. So now we searched for the literal and we found it as teeth is equal to many. Teeth is equal to many. And if you see here, teeth is equal to many, then class is positive. But actually, my dear friends, if I say teeth is equal to many positive, see, here there are teeth is equal to many, negatives are also there. How do you say? You cannot say this in general. This, no, after being found a rule called as gills is equal to yes. So we have eliminated all negative cases, all such negatives. See, all such negatives deleted. After that, we found this literal again. Now, so this cannot be used as standalone. If I use it as standalone, see, it covers P1, P2, and P4. Not only that, my dear friends, it also covers N1, N2, N3, N4. That's why I am going to use this rule with a precedence of else. See, I will precede this with an else. It actually covers more negatives than positives. See, it covers 3 positives and 4 negatives. So that's why, in other words, the rule implicitly assumes that previous rule does not fire. Previous rule does not fire. No, we have eliminated. No, the previous, according to the previous rule, we have eliminated all these things, N1, N2, N3, N4. Then we found this particular rule. That's why we include what is called else part, else. In the final rule model, we will precede it with else. Now we can say this is negative. Instead of empty, we have to say it is negative, not empty, negative. And else, if teeth is equal to many, then we say it is positive. If teeth is equal to many, then class is positive. Now, we are now left with 2 positives and 1 negative. 2 positives and 1 negative. This time, it makes, no, can we have, no, what are the 2 positives? And if I say, this is P3 and P5. What are they? Length equal to 3. See, if I say here, length is equal to 3, L3, P3, all right, P3 and P5. 2 things are there. So, can we find a common rule for this? See, if you see here, P3, P5. P3 is length is equal to 3 and gills is equal to no, wake is equal to S and teeth is equal to few. Similarly, length is equal to 5, gills is equal to no, wake is equal to S and teeth is equal to 5. And negative is length is equal to 4 and gills is equal to no, wake is equal to S, teeth is equal to 5. Suppose if I make a literal called wake is equal to S, wake is equal to S, then it covers P2, it covers P4, sorry, it covers P4 and it also covers N5. It also covers N5. So we cannot have this literal. We cannot add because it covers both positives as well as negatives. Now you take teeth is equal to few. Teeth is equal to few. You take teeth is equal to few. See, in this case also, if you see here, it covers P2, P3. It also covers P5. It also covers N5. So we are left with length is equal to 4. Length is equal to 4. Then it covers only one negative. It covers only one negative. Let us see now. So this is how we have to analyze the things. Now, length equal to 4, then see it is negative. It is negative. Length is equal to 4, then we say class is negative. Class is negative. Since the remaining examples are all positives, we can invoke a default rule to cover those examples for which all other rules fail. See, if gills is equal to yes, then class is negative. Else, if teeth is equal to many, then class is equal to positive. Else, if length is equal to 4, then we say class is negative. Else, or in all cases, the class is positive. Hope you understood, my dear friends. You understand, right? This can be written as true. 2 plus. Now length. See, all pure. Length is equal to 3 pure. Length is equal to 5 pure. Length is equal to 4 pure negative. And gills no. 2 plus 1. Back yes. 2 1 minus. 2 teeth is equal to 2 1 minus. And we can write the graph as simple as this. This is, my dear friends, 45 degrees. So this is what it is. So this is called rule models. Hope you understood, my dear friends. Thank you.